Hello and welcome to Mouse Input. So this is a lecture I actually missed the first time I did this, so I'm kind of compensating for it. Here in Unity, basically we're given two different types of mouse inputs. I have created a plane, nothing fancy, and I've created a cube called Click Me, which has an appropriate script on it. We'll talk about it in a moment. I think I moved I don't know if I even moved my camera, but if I look at my camera perspective, I see this. So you want to make sure the camera can see the cube and can see the plane. The plane will be lighter, actually. It would just be a generic plane. The cube will have a rigid body and use gravity. So will freeze the rotations on it. So that is kind of our setup for this tutorial. Again, please pause the video if I'm going too fast. Again, there's two major ways of actually doing mouse input. Unity has a set of callbacks, so if I click a specific object, something will happen. And then the second type would be the raycast, where I click, say, on this plane, and I want to get this location I clicked. Well, from the camera to the point I clicked on the screen, I can raycast until I hit an object, in this case the plane, and get a point. So the easiest, the first one we'll go to is the callback functions, because this is similar to what you might see in Java per se. So I have a script called mouse select. Bring that up. And these are the different functions that you have available to you: on mouse down, on mouse drag, on mouse enter, on mouse exit, on mouse over, and on mouse up. So on mouse down is called when the user presses the mouse button while the mouse is over, or the mouse icon is over the UI element. On mouse drag is when I click on an element and drag the mouse. On mouse enter is when the cursor itself enters into a certain element. On mouse exit is when the cursor exits the object. And on mouse over will be true if the mouse cursor is currently over the object. On mouse up occurs when I release a button. So these are the callbacks I have available to me. So here I was doing some different testing, but basically what I did is on mouse down, I have a rigid body on this, so I say my rig equals this component dot get component rigid body, and then on mouse down I'm going to say my rig dot velocity equals new vector, and I'm just going to give it a random range and basically toss the cube left and right, or up or forward and back, or up and down, left and right, and I'm not going to push on the Z. So it just gives it so basically every time I click on the cube, I should see it randomly roll. Again, I'm using one of these mouse callbacks to actually initiate this. So if I save it, and I run it, now, once again I click the cube, and it just goes flying. And click it again, and I'll have a new direction. So I can just keep hitting the cube. And if I engage, use gravity, there we go. It doesn't actually do much. I have to add a little more velocity, but you get the idea. So this is using a mouse callback. Now this is the easier of the two. The second, I'm going to use this screen here as a demonstration, is the raycast. Now here, I'm not just selecting an object, I want to set a location. So say if I do a right click, I want to get this location, for example in a real-time strategy game, I want to get this actual coordinate, not click on the plane. Since I want to get the actual coordinate of this, I have to take from my main camera, let's just say for a moment that this is my main camera, and in the center of that camera, and then a point where my mouse is pointing, basically. Actually, I should take not the center of the camera, but the focal point of the camera, which is behind the camera. So where my mouse is on this frame, I'm going to draw a line into the scene, And whatever object I hit, that's going to be my point where I find my, that's going to be the collision where I find my point. This is very similar to the raycasting we did in light in graphics, if you remember right. We had to do things like this. So I can't really draw it out right here, but remember the idea is we're going to take from the focal point of the camera to the mouse through the point of the cursor on the mouse, and then whatever object I hit in the 3D scene, that's going to be my point. This is a common picking technique in graphics, and we talked a little bit about this, like picking an object. And so this is, like, for example, I'm sure Unity is using this exact functionality in order for me to allow to click different objects. So how do I do this? Well, we open up my code. Again, I have another script. Again, please pause if I'm going too fast. Raycasting is going to use a package called physics. So we don't have to import anything special for this one. But we're going to have a game object called click spawn. This is those yellow spheres I showed you. I made a prefab out of it. When I click on a field, I'm going to just spawn a prefab. So this is something I assigned in my scene. If I go back to Unity real quick and click on the plane, you should see I've made an object called, I don't know, click spawn. It's just an empty object, it's a sphere with a yellow material, and on the plane I assign this prefab to this this script. So wherever I click, I create one of these circles. So back to my code. On mouse down, this could also be on mouse, I think it's on mouse right down. I think there's a way to do it for right button as well. I'm going to say raycast hit. This is a variable type, my check. This is going to be the point that I collide with. So if I do physics.raycast, then I have to take the first elements to camera, and this, or the point from the camera to send out the ray. So in this case, it's going to be camera.main.screen_point to ray. There's actually another way of doing this, but this is an easier way to do the screen point to ray. So I can say camera.main screen point to ray. Again, I can use any camera, it doesn't have to be main. And then input.mouse position. This is going to create that ray I was talking about. And then for an output, so this shorthand in C# for output, I'm going to send in my variable, my check. So if I collide, if this results in a collision and I hit an object, this will be true. And if it's true, this will be populated. Otherwise, this will be false, and I'll skip this whole thing. The one weakness to the raycast is it has to hit an object. If it doesn't hit an object, it just doesn't know what to do. So if it does hit an object, then I go debug.log, we hit, and my check.point.x.y and .z, this will be the point I hit. And then I do gameObject.instantiate the prefab I want to instantiate, the location I want to instantiate it, which happens to be the point I hit, my check.point. Also, my check can give you several different things, I believe. So it can give you a collider. It has to collide with the collider too. That's the other one. It has to collide. So it gives a collider it hit with. It can give the distance it hit. It can do some light map coordinates. It can give you the normal of the object. I think the object it hit, if I remember correctly, the point, which is what we're using, and then the rigid body of the thing it hit, and some textures. It can actually use textures too. And I believe the transform will actually be, the transform of the thing that was hit. And this can even give you the triangle index of the mesh that was being rendered, but that's a little too low detail, it's lower than we need to worry about. So we can get quite a bit of information from this variable. But in this case, we're doing my check.point will give us the point of our collision. I print it out, and then I spawn this click spawn at this point with identity for the quaternion. Let's save this. And once again, this is on the plane. I've added the raycasting script to the plane, and I've added my prefab to this click spawn. I'll hit run. Now if I click on a plane, I will see a sphere appear. Also, I should see it print out. Let me collapse this. Clear this actually. All right, if I click here, I'll see, again, we see the point where it spawned, and I can keep spawning new spheres as I go down. So again, it has to collide on an object. If I if I try to click on the background, nothing will happen. If I tried to click on the background and had this script attached to my camera or something, it still would not work. I have to collide with an object to actually make this happen. So those are the two primary things we're going to do for mouse input. Remember, you should memorize all of the different callbacks for the mouse. You should have these memorized, and you should try to commit this to memory, or at least the general form of it. If you have to look up the physics raycast, it's not a big deal, but yeah, you should know that's under physics.raycast in order to get this, in order to do the raycast. And that will conclude it for mouse input.